Included in the release of ASAP 2013 is a new method for defining polychromatic sources in ASAP. Within ASAP, a source is defined as a collection of rays. Each ray has a starting point and an initial direction vector associated with it, an initial flux or power, but within ASAP, each source is defined only at one wavelength. If you need to do an analysis on your system based upon multiple wavelengths, then what you need to do is to define multiple sources, each source at each specific wavelength. This will still be the case in ASAP 2013, but we've included a lot of tools in ASAP now to define multiple wavelength sources, especially those based on CIE standard illuminance or possibly mathematical functions. Now let's take a look at how all of this works. What you'll see in front of you now on this screen is basically the spectral distribution of several sources using the temperature correlated D sources. And in particular, we've created a series of sources at 5,000, 5,500, 6,000 Kelvin, etc., all the way up through 20,000 degrees Kelvin. And you can see all of those over there. What I'd like to do now is to show you some of the basic functionality that's included with the source polychromatic and how you'd go about setting up a polychromatic source within ASAP. And let me open up a small file here, and we'll talk about some of the changes within the ASAP file. The first are two changes that would occur within what we refer to as the housekeeping area of ASAP, and these are commands that need to be issued before you define the polychromatic sources. The first one allows you to set a maximum number of polychromatic sources. You can set this to any number that you would like, but keep in mind that as you define the maximum number of polychromatic sources, ASAP will be setting aside memory space. So just because you can say you will have a maximum of 1,000 polychromatic sources, for example, if you're only going to have 2 or 3, I would recommend you set it to a lower number. The next option is to set the maximum number of CIE configurations. ASAP will allow you to save information about any number of CIE configurations, but this is the first fundamental change that you would notice if you wanted to use a polychromatic source. The other is simply down in your source definition itself. First off, your polychromatic source must start with a typically defined ASAP source. So in this particular case, I've simply defined an elliptical grid of rays coming from a point source. Then what I do is I define my spectrally weighted source. In this particular case, I'm going to use a CIE D50 source. Okay, built into ASAP are functions for the CIE A, C, D50, 55, 65, 75, and E sources, as well as the standards for fluorescent F1 through F12. If you wish to use any of those lighting distributions, then you'll simply be able to call those in from the built-in functions, and that's all you'll need to do. In this particular case, the rest of the command says, I want to define a default source power of 100 watts in this particular case, and I want to generate 97 sources in a wavelength range from 300 to 780 nanometers. Okay? And what we'll do is simply run this file and take a look at the results. Okay, so the first part, we're simply looking at the rays, and in this case, the ray vector length indicates the power of the source. And as you'll notice, the different colors extend different lengths because different rays of different wavelengths have more or less energy. And I also want to come back here, and we should always look at the numbers. So what I'm going to do is open up my command output window a little bit here. And there is a new command that's list sources polychromatic, and this is simply going to give us the wavelength, ray, and source ranges that are associated with each polychromatic source. In this case, I only have the one polychromatic source. It covers a wavelength range from 300 nanometers to 780 nanometers. We have a grand total of 9,400 rays associated with each of these sources, and they are sources numbered 1 through 97. And we can see the information about the energy in each of those sources listed in this information right here, which is simply asking ASAP to give us the statistical information about our sources. So that's a brief introduction to what the source polychromatic can do for you. In this particular case, we started with a simple elliptical grid of rays, but any type of source definition you can create in ASAP can be used as a polychromatic source. In this particular case, the source polychromatic we're using is based on the black body spectrum, and in this case for a temperature of 5,400 degrees Kelvin. And again, I'm going to set a default power to 100 watts. I'll do 81 sample sources. And again, my wavelength region will be from 380 nanometers to 780 nanometers. And we can again look at the same information. I'm going to look at a plot of the rays. I can also look at the polychromatic source information as well as statistical data. And let me end ASAP to clear everything and run again. And since both sources are there, we're going to see the original source information as well as the information about our black body type source. And if we zoom in on the black body information, we can see that we have, again, a difference in energy associated with each source as a function of the spectral power in each particular wavelength. We can again look at the data that's reported out in the command output window. In this case, because we have the two different polychromatic sources, we have the information about each of the sources. You'll notice we are going to have multiple sources at particular wavelengths, depending upon what our wavelength spectrum is, and that's not a problem, and we can isolate ray information, again, either based on its source or based on a wavelength. And if we have a common wavelength, then we will get information about all sources that contribute at any particular wavelength. And again, the distribution of energy at each particular wavelength, the first group being from our first source, and the second group of sources come from our black body definition. Now, within the source polychromatic, we've looked at, so far, a black body type source, Planck distribution, where you simply need to enter the black body temperature. As I mentioned, a wide range of CIE default distributions are built already into the software. I listed them previously. They're also all indicated in the online help. You can also have data as either a text file or as a table built into your ASAP file. The format for the text is identical to what you see here in the table. It's simply the wavelength and the relative power at that wavelength. For instance, maybe the D50 source in ASAP is based on 5 nanometer intervals. If you have data at 1 nanometer intervals or some other interval that you would prefer to use, you can simply create the text file or the table of data and use that instead. Also, since it's listed here, you can also randomize the data in either position, direction, or both. What that means is we have a default source described right here. If I do not have randomization applied, then each and every source will have exactly the same ray starting points and ray directions. If I randomize that source, then I will see a randomization of that information. So the rays will start at different positions, possibly across the body of the source, as well as propagate out with different initial direction vectors. The other type of source definition you can use is to define your own user function. So in this particular case, I again have a simple emitting disk as my base source definition, and I have defined a simple function that is simply a Gaussian based on the wavelength in nanometers divided by 1,000, and I've turned that into a source polychromatic based on that function, the name of the function, the initial power, the number of sources to be generated, and the wavelength range. And again, what I'd like to do is run the file. So let me just end and run here. And in this particular case, if you think about the function I've defined, it's one where the light at the low end of the spectrum, the purple light if you will have more energy than the light at the red region of the spectrum, and we can clearly see that in our energy distribution here. And again, we can take a look at the energy distribution into each of our defined sources. So you will still need to have a separate source for each wavelength of interest, but with ASAP 2013, it's going to be much easier for you to define those sources, especially if it's going to be based on a reference standard such as any of the CIE standard illuminants.